Yeah, so we're going to record all the meeting times, and they're going to all be posted on the Victor website for people to look at them. And so if some people cannot be there during the full 2 hours, there's no problem. They can always look at the recordings. In terms of because I got the question from Jason, like in terms of how the class is going to be taught, it's going to be probably a mix of lectures and hands-on sessions. But I think if we got some assignments, we're gonna, give them to you as optional assignments that you can, do at home as well, and we can talk about it the week after. So it shouldn't be live assignment that you have to hand out at the end of the class or things like that. So it's pretty open in that way that you can attend classes, but you don't actually have to do the assignments and give anything back to us. If anybody wants to get credit hours from that class, let me know because there's actually a class number associated with this short course this semester, so I can give you the class number, and I think that only works for US students, I guess. But probably with the class number, the official class number, you may be able to get credits from the class. I'm not exactly sure how that works, but if you're interested in getting credit hours from that class, let me know and we can start the discussion on that. Just send me an email. All right, so I think unless...
Hey, Sylvain.
Yeah.
I was just going to add to that. One thing I think a couple people did last year was they just talked to a faculty member, like their advisor, and had a special topics class with their advisor, and that was taking this class. So that's another way to go.
Okay.
That may work at your university. Just depends on what you want to do.
Yeah. Sure. Yeah. That would be another possibility. Another thing we can do also is give you a certificate at the end of the class. If that's something that you think could be useful for you, is once you reach the end of the class, we can actually create some certificate with your name on that state that you took that class. And so, yeah, that's probably something we can do. So email me for that, and we're happy to help you on this. So unless there's some other participants that cannot really do it from 10 to 12, I think we're going to keep it that way. I cannot really put it earlier because then that would be really early for people that are in the Western US. And I think this is a good time, like for Europeans. It's not too late for Europeans, and then it's not too early for US people, most of the US people. So I think we're gonna leave it like that, and then unless there's some strong suggestion to move it to another time, then we're gonna keep it that way. So I'm gonna share a tentative schedule that we put together. It's a very early version of it. We're still working on it, and we're still learning from you guys what your interests are to actually change and adjust that schedule. But so the goal is to meet every week at that date and time, and then to talk about different topics. So you can see here the date on the first column, then the topic on the second column, then the models that we're gonna probably talk about for each of these topics, and then the class leaders on the last column. So, for example, today we were thinking just to give you an intro on Victor, tell you what Victor is all about, and show you the how to join the hub, or to get an account, and show you what the hub is all about, and the different features that we see on the hub. And then starting next week, move to some particular topics and particular volcanic processes. So we're thinking that we could start with ordinary differential equations. with Chuck, showing you a few workflows for that and a Jupyter notebook, and then moving to magma ascent, magma degassing, and then surface processes like tephra fallout, volcanic plumes, PDC and lahars, and lava flows. And then, of course, I know a few of you are geochemists and are interested in magma differentiation. So I've been working a little bit with two models, MELTS and the magma chamber simulator that are still not on Victor, but I know a little bit of them, but I don't really feel confident talking about them. So we're still waiting to get somebody that could really give you a good introduction on these models and talk about that. So that's why we put that towards the end here of the second half of the class. And then after, there's some like empty spots here during April. And what we were thinking is having some session where you could actually do a presentation of your research or on the model you're working on, and give us a little bit more detail on how you want to use Victor, and probably starting some discussion and probably show you some other activities and tools that are on Victor that could be useful for you based on what you told us about what your research is and your interests are. So I really leave this like 4 empty spots here to actually really get more detail about what you're interested in, and leave this open to for you guys to participate and really probably even lead some of the discussion there on that second part. This schedule is just
Can I just add something?
Yeah, Chuck.
So, obviously it's, everybody's got, their super broad interests represented in the class, and we're not going to be able to cover all topics. I'm sorry, I don't remember who somebody mentioned inversion, maybe in the context of geodesy or something like that. So there are tools on Victor to help with that. And we can, the people who are involved in the class at whatever level can help you develop a workflow for your thing. And I'm just using inversion of geodetic data as an example. And I think that's a super exciting part of the class, because we can go through the tools and things like that, and that's cool, and you'll get an idea of how Victor works and what it's all about. But we really want you to be able to use it to further your research. And so that's just an example, and I think it's going to work great. That's what we're trying to do, is get you guys a tool that you're going to use in your research. Sorry, Sylvain, go ahead.
Yeah, no, that's a very good point. And I think, from the questionnaires that we all the answers from the questionnaire we got back. Thanks very much for sending that, by the way. That really helped us to get more information. So based on the answers from the questionnaire, we can see that most of you are not very familiar with Python, and so or have just little experience in Python coding. Some of you are using all the codes, only a few of you are good experience. So that's why we really want to take it slow and get to the basics of creating a Jupyter notebooks. And I think we can show you some examples of that, and probably on Chuck next week is going to show you the basics of creating a notebook. So don't feel overwhelmed if you think like right now creating a notebook is like kind of too much effort. We leave it free for people to either create a notebook and go further and put something on Victor, or if you're just interested in seeing what's on Victor without really contributing and writing something, that's totally fine too. So we want to leave that class open to both new coders, and then also experienced coders that could do more. Right, so that's the tentative schedule. One thing I wanted to ask you guys is the Cities on Volcanoes coming in February, and I would like to know how many of you are gonna go to Cities on Volcanoes. So if you could just, I guess the best will be to use the raise hand tool on Teams. If you can raise your hand if you're going there, so then we can see how many people are actually attending Cities on Volcanoes. Because we're basically wondering if we should do classes during that week of Cities on Volcanoes or not. So so far we have only 2 people that raise hands. Okay, so it seems that a lot of people are actually not going. 1, 2, 3. Okay. So I think we should keep the class during that week, and I think Chuck is the only Victor team member that is not going to Cities on Volcanoes. So I think Chuck is gonna be the one that's gonna do the class on that day.
We'll do cool stuff while you guys are partying at Cities on Volcanoes. We'll do cool stuff.
Wednesday field trip. So
yeah, Wednesday is a field trip day actually. So yeah.
Nice, nice. Well, that's always better. But are you talking about Victor at Cities on Volcanoes?
Yeah,
oh, cool.
I have a presentation, and then the day after Cities on Volcanoes, we also have a workshop where we Victor and then have people do hands-on exercises to use it. So if anyone who's going and wants to also come to the workshop, they're welcome.
Yep.
Cool.
All right, cool. Yeah, so I think we're gonna keep this week there on. So actually, that's the week where we're supposed to talk about magma degassing, and I think a few of you are actually working on magma degassing. So I think that could be one topic. But Chuck, feel free to change that if you think you'd rather talk about something else on that week. So I can share that that tentative schedule with everybody, and you guys can tell us, if there's something that you think is missing in there that you really want to hear about. Let us know, and we can change that. Like we said, I mean, we really want that course to be your course, and we really want to tailor it to what your needs are in terms of research or teaching. And so please let us know if you think we're missing something important you wanna hear about. We're gonna focus mainly on the codes and models that are already and the tools that are already on Victor, but we're also open to talk about models that are not on Victor yet that we either plan to put, or if you want to contribute to putting one of the code that you're working on that is not on Victor, that's also something we can do during that class. All right, I think next is to introduce Victor. So I have a very short PowerPoint presentation that I'm gonna start, and then after we can move to a live session on the Victor Hub. So let me share that PowerPoint presentation. All right. Don't hesitate to speak out or raise your hand if you wanna say something. Okay, I'm actually trying to. I mean, if I put it in full screen, I don't have the. Oh yeah, I still have the little thing, so I can see if somebody is raising his hand or not. So this should be okay. All right, so Victor, what is Victor? Victor stands for Volcanology Infrastructure for Computational Tools and Resources. And it's a project by Einat Lev and Sam Krasnov at Columbia University. And there's collaborative universities, including USF and Chuck and me, and also Tufts University. with Abani. Patra cannot be there today, but he'll probably be there at some other session. And it started as a NSF proposal for EarthCube from the National Science Foundation. And then we got funded for 2 years, and then we got another project through NSF. I think it's the Open Science something that is for another 2 years. So to learn more, you got the address, the address for the website down there, and I'm going to show you that next. victor.ldeo.columbia.edu. And there is a contact as well, victor@ldeo.columbia.edu. If you want to send any questions or any comments or suggestions, you can use that contact there. What are the goals of Victor? What we want to do here is to try to make it easier to run numerical models for everybody. So create a platform so then we can not only share models, but also document models and create some workflows and some tools that make the models more accessible. We want to broaden model literacy as well, so that a lot of people could actually learn about how to run a numerical model, how to get the output of a particular model, and how to use that for research or for teaching. And then finally, we also aim to reduce volcanic hazard by making model more accessible. So we focus mainly on surface processes right now, because I guess that's what the development team research interests are. But it doesn't mean that we not focusing also on conduit processes or magma differentiation. So right now we have mostly models for surface processes, but we aim to expand that for sure to any model that is related somehow to some volcanic processes. So Victor's value proposition is to help volcanologists at universities and observatories to find, use, compare, and link models of erosion processes by providing a central access portal and standardized workflow based on the Jupyter Hub environment. So here is the design of Victor. So we start with a user portal, which is a Jupyter Hub, similar to AWS in some ways, but it's mostly using Jupyter resources. And from there, we're going to populate that Jupyter Hub by having some tools library and a model library that is going to be integrated into the hub. And from there, we're going to develop some workflows, online workflows, and we're going to also get some link to fetch some data from different sources. Could be monitoring data, could be remote sensing data, for example, that are used as inputs for some of these models into the workflows to actually get some outputs and an output library that's going to be stored on the cloud. So everything is actually stored on the cloud, and you don't have to install anything on your own machine. All you have to do is to logging into the Jupyter Hub with your account, and then from there you can download, upload files, run workflows, create Jupyter notebooks, also do a lot of things. Yeah, and Nathan, Chuck, if you have anything to add to one of these slides, please do it. So this is the organization of the Victor website. I'm going to show you that website in a few minutes. But basically what we have is a development and management team, which is basically us. And we have an advisory committee that is supervising our activities on Victor. We have some partner instructors, different universities working with us. And then we have a hub portal, like I said, that regroup most of the models, the tools, and some data. And then we have some documentation as well about the models themselves or some of the workflows we created. And then we have the sign up page that is the one the most interesting for you to actually get a Victor account. So in order to get a Victor account, the best is to actually go to the website, the Victor website. So you go to victor.ldeo.columbia.edu and you click on the sign up button on the top right page there. And then you're gonna have to fill up a quick registration form. The only thing you will need in order to get a Victor account is to get a GitHub username and password. So you need to get a GitHub account first. And Sam, correct me if I'm wrong, but I think that's a requirement still to get that GitHub account in order to be able to use Victor. And then you can, once you do that, you fill up that registration form, you're gonna have to wait for a confirmation email that's gonna tell you that you have an account. And so the next step actually is to actually go on the Jupyter Hub to log in. So I'm going to show you that step after that. Another thing we have on the website is some documentation page where you can actually get a lot of ideas about the usage, content, and the various application of Victor. So this is still a work in progress where we still populating a lot of things in there. But you can see already the contents here, a screenshot of the content from last year. Maybe this has grown already. I haven't been there recently, but you can have a lot of things about the usage, the models, and then the different libraries there. So don't hesitate to go to that documentation page to get more information about, for example, how to run the models, etc. We're going to give you a few information today, but it's always good to also go on your own and get more information from the website itself. Right, so that's where you're going to start, Victor. Once you get an account, you go to that email address, which is victor.2i2c.cloud, or the Victor website homepage. You click on the hub portal and you click on login. And then from there, you can choose different service options to start with. And that's basically the cloud machine that you're gonna use to actually run tools on Victor. So you can select a small one with only 2 CPU and 8 GB of RAM, all the way to a huge one with 16 CPU and 60 GB of RAM. So the small one is enough to do most of the things on Victor, especially even running models. And it's only if you really want to do like probabilistic hazard assessment, probabilistic modeling, that you may want to use the large one or the huge one. So I suggest just to use the small one for the moment for most of these. Then you have to wait for the server image to install. And once that's done, you're going to be on the Launchpad, which is the hub, the Jupyter Hub for Victor. That looks like that. Then we can then tell you what are the different options and features of this Launchpad. Just want to finish by saying that Victor also provides ready-to-use computational resources and modeling environment to use during run-up and eruption. So there's a collaboration with the Converse effort, and there was some collaboration during the recent Kilauea 2022 and Iceland eruption. Even the last one, I just saw that there was some people that posted a lot of resources on Victor during the last eruption a few weeks ago. This is something that Victor can provide. And there's some current collaboration with Converse and USGS to actually make this more useful. What we also provide is ensemble and probabilistic modeling to provide uncertainty quantification during peace and crisis times. So this is still a work in progress, but we actually plan to install some probabilistic simulators that you can use with some of the models we have. For example, for Titan 2D, you can actually use a tool to run it probabilistically. So that requires, of course, using a lot of computational resources. So if you have a plan to do that on Victor, please let us know before, so then we can organize the resources and tell you what how we can do that. But it's something that we actually plan to do in the next 2 years. And then finally, we want to offer trainings for more modeling savvy workforce and public. So the short course is part of it, but we have also workshops that we did, for example, last year in Boston, and we're going to do more of these workshops during the next 2 years. So we're going to keep everybody posted on that via the listserv or other websites for some forthcoming training and workshops on related to Victor. All right, that's all I had. So I'm going to stop sharing my screen.
Yeah, one small addition I can say that I don't think it was in the slides, because Victor is in the cloud and a lot of data and data repositories are in the cloud or accessible. It's very easy to have tools on Victor that grab data from other resources, and you don't have to end up, you don't have to download huge DMs or satellite imagery into your own computer at home or the university, because everything is already cloud accessible. So we have a few examples on Victor for tools that use API or application interface that grab data and use it on Victor. So that's also kind of giving you a lot of flexibility and save a lot of effort of downloading huge amounts of data locally.
Yeah. Thanks for the addition. Anything else? Any questions from anybody before we go to the hub and show you the different capabilities of Victor? Okay. Felix, you had a question?
No, I just was wondering, can you hear me?
Yep.
Yes.
Okay, I was wondering, when you show the computational capabilities that you may need for using GitHub, is if you have ever tried to use GitHub in the Colab in Google, because sometimes Google offers free resources with very decent memory RAM. So if they don't have the computational resources in personal machines, probably they could use Colab project if they work in a Gmail account. And probably this could be a useful resource if their own computers are somehow limited in terms of the RAM of the memory access.
Cool.
Yeah, Chuck or Elena, you want to answer that?
I can also say something. I think that Colab is actually, it's very solid for a small subset. The reason I think Victor is better in this case is just that it has more flexibility, and we also have it's going to have desktop applications. Right now it has QGIS, and we're close to getting ParaView and other just like geophysics applications on there that are more useful, and it's keeping everything a bit more contained and also a bit more customized. Whereas I feel like the Google Colab is best for smaller projects, I would say.
And you'll also have to install everything yourself, right? Well, in Victor, the idea is that we already
more or less.
Right.
Yeah, I think the only the last thing I'll say, the only thing I think that Colab might have that we don't right now is like some limited GPU like CUDA type stuff.
Yep.
And maybe this was clear from the presentation. I just want to add though that this point that comes up about not needing to compile your own code or download the code from GitHub and compile it is super important. And in the sort of laundry list of models that Sylvain showed on Victor, I mean, it's interesting. They're all written in different languages that require different resources. A code like Molasses has different requirements than a code like Tephra2 or IMAX, and basically they're already compiled on Victor, so you can use them without that headache of how do I get my code to work, and this code that I'm downloading from somebody else. So we think that's a huge step forward for those of us who have been very, very frustrated by trying to compile somebody else's code. And the other thing about a Jupyter Notebook, which you'll see, is you'll be able to write relatively simple scripts in Python and cause those codes to run, even though they're in C or something like that. And you'll be able to use them seamlessly in a workflow. So that's pretty exciting. I'm not really sure exactly where that kind of approach is going to wind up, but I think it's like just blows open possibilities for people. So you might not be so limited by these frustrating details, which are important for the code, but not for you.
Yeah, definitely. And especially when you're a grad student. I mean, I remember when I was a grad student trying to install Titan 2D and spend months before I could get somebody at Buffalo who could help me, and then finally managed to install it on my computer. But there was still some error messages coming up and everything. So having a platform like Victor for when you do your master or your PhD is pretty awesome when you wanna run a model without having to go through the compiling and installation issues. Yeah. I put on the chat the link to the Victor website and then to the documentation page, and then I can also put a link to the sign up page. I don't think I can do that because it actually asked me to sign in. So, but you can just go to the Victor website and then click on the sign up page and start the registration form process to get an account. If you have any questions, put it on the chat. I'm also going to share that these presentations. What I was thinking is that probably we can use a box folder, or unless we want to use a Slack channel, I don't know. It's up to you. We can do either thing, but we can share like all the presentations and I guess the notebooks. Then we can share them directly on Victor once everybody's got an account.
Yeah, I mean, actually, last time we used the Slack channel, and people weren't so interested in using it, so that wasn't very effective. Maybe the box will work better. I think just
okay.
We'll just have to see. We can go either way.
Okay. Yep. All right. Cool. So what I want to do now is show you the hub and all the different capabilities that we have. So maybe Sam, you want to do it if you don't mind, because I'm sure you got a better knowledge of everything that's on the hub. So I don't know if you're able to share your screen and show the hub. Otherwise, I can do it, but and then you can skim in if you want to add something as you want.
Yeah, sure. Sorry, I was just trying to make everything not look cluttered on my screen.
Okay.
Okay. 1 second. I want to show what it looks like from a fresh login perspective. So I'm logging out quickly.
Okay.
Okay. Share screen. Okay. Oh.
Yep.
Oh, can you see?
Yep.
Okay. So basically, the moment you log in, you'll see something. There'll be a login. I already logged in, but you'll have these 4 server options, and then let's just start with the small. Once you press start, it will immediately just start getting everything running. It just has to go through a script to basically spin up all of the things we need. So if you want all the technical goodies per se, then you can click on the event log, and it shows, it shows that there's already some nodes. It needs to open up new ones, and then basically just scale up what's called pods here. I already have another account right here with everything running. It usually takes this, maybe 4 minutes. We're going to try to kind of slim it down so it takes at most 2 minutes in the future. But right now we just have one big machine with kind of a stupid amount of different resources, and we might try to compartmentalize. So anyway, when you log in.
Sam, I got a question for you. So when you say scaling up is actually scaling you up to a better machine? That's what it's doing, basically?
It's, when I say scale up, I mean it's just allocating new cores for a new machine.
Okay.
I don't know the exact scenario, but we have a chunk of because of our partnership with 2I2C, this infrastructure, like our infrastructure partner, they set aside, they have a group of cores, and whenever we ask for a new machine, they just say, okay, they're asking for a small machine, we'll give them 2 cores, we'll give them 4 cores, and this much RAM.
Yeah.
And then it pulls the image of the machine, and then anyway, when you log into the machine, oops, sorry. Okay, let me clean things up with that. You will see just this launcher, and then you'll see only 2 folders. It will be shared and shared read write. You can see over the days, months, and years, I have lots of other things here, but all you'll see when you log in is this launcher. And from there, you can open a notebook. So you can just say, I want to create a new notebook, and then click on that Python tab, and you'll open a brand new notebook. And in this case, we're using a Python environment with a bunch of libraries, but you could just as well do that for your own environment or for R. And we'll try to, if we see support for it, then we'll also add libraries for R. But you can also create a normal kind of console interactive environment for Python or R. But you can also just open a terminal. This is a standard Linux terminal. You can, ls, pwd, all of those commands work just as you would think. It's running a pretty standard Linux distribution. Anyway, what you'll all be most interested in is in the shared folder. That's where kind of the heart and soul of Victor is. So right now what we have in here is a README with just a few notes about the platform. Right now, you can read this in your own time, but this is what it looks like. You can also load it properly, I think, to preview. Not right now, I guess, but so we have, I'll just go from the top. We have a folder with some DEMs. These are right now just a small subset of, heavily used ones in the community. But if you, are using one a lot, or you want one that's not on the platform, we're happy to include it. We're just trying to make, a centralized area so people don't need to go somewhere else and download it. There's a folder here from Iceland because there's been intermittent eruptions happening over the past few months. We have a libraries folder for just a couple of files right now. The main one is victor.py, which has a bunch of scripts and functionality to just simply make everything easier. All of the documentation is on our documentation website, but if I scroll through, you can see we have things for plotting DEMs, plotting flows from various models. If I scroll down even further, yes, have some functions to download or upload files from cloud providers, like this one is for Google, but the list goes on. And this is what I kind of keep adding to as we add functionality and we realize things need to be made easier on the platform. Continuing on from the libraries, we have really what is the core, which is all these models. Make sure they're custom fit for Victor, and this is where the source code of all of them is. We have scripts, so we have a Victor script. So if you just run Victor in the command line, you could do. You have to actually do Victor setup if you want to set one up, but you can see we have this full list, which actually I think is needs one or two more models that we recently added. But you can see just by typing in 2, you can set up disgas, which is a degassing model, and it should be that easy. But if you want to make tweaks to the code at any point, because one of the core pillars of our platform is being open source and very accessible, you can just copy it over and then start making changes. So continuing on further, we have scripts, which are mostly just little things to help set up various models. You can see here they're all for just mostly for setting up models. We have I've made a few for like checking GitHub, just automation, but this is mostly for myself, and you guys don't need to worry too much. And then we will probably add to this folder throughout the course. This is the Victor Short Courses folder. This is from last spring. As you can see, Chuck did a great job kind of breaking the course into different parts. It'll just be in different folders. We'll figure out as time goes on how exactly we'll segment everything, but you can expect most of the content to be in here. And then,
hey, Sam, can I just add something there while you're on those?
Please do.
Sylvain earlier mentioned that there's lots of different levels of Python and stuff like that in the class. And I don't think explicitly in lectures we're going to cover all of these sorts of notebooks, but they're designed to help you come up to speed. Like if you're scratching your head right now and saying, what's a notebook, and what do I do on Victor, and how do I use this tool? If you can navigate into like part 1 intro notebooks, you can bring up one of those notebooks, and they're generally, perhaps easier to understand or to get you into using the Python a little bit and to familiarize yourself with Python. So obviously that'll be an easier experience for you if you're used to using R or MATLAB or something like that. But I think if you're starting from scratch, I mean, the idea for success in science is to copy what you can and stand on the shoulders of other people. And so that's why a lot of these examples are here. So I hope you can use them. Yeah, I guess we'll talk more about that later.
Yeah, on that same note, we have the segments from the lectures from last year's class. They're all the videos are available under our website under education. So if you want to get, and they usually cut to like a 20-minute or so segment. So you can go to the introduction lecture or any other lecture, any topic, and get kind of catch up if you feel like you need that in preparation. But also we will cover a lot of these basics today and next week, and then following on. Also, we're more than happy to direct you to really good resources about Python and Jupyter that are available through other parallel efforts in the community.
Yeah, what everyone just said, I feel like, especially for the standing on the shoulders of giants, this is kind of a double version of that. We're trying to stand on the shoulders of everyone who's made these models and made these efforts to get to be able to make this kind of platform, but then we're hoping from there people will stand on our shoulders and then be able to make much more comprehensive products and models and whatnot because of the the efforts we make here. And then last but not least, so the workshop has a couple of various files if you want to see what we did during our workshop this past summer, but the workflows are the other kind of main pillar of Victor, where I'll go to IMX. So this is one of the ways we run our model. So rather than making you figure out, okay, I have copied the model over, I've run the script, what do I do now? We walk you through, make sure that you understand exactly what you need to do. And, we try to set up initial values in all these, so you don't even need to change anything if you don't want to. But we try to make it as railroaded as possible if you want to. And then if you have complete understanding of the model, or you have better understanding than none at all, you can, start tinkering more with it. But we try to make these notebooks and just try to compartmentalize things a bit more, make it easier to consume. You can see here we do like a little sanity check on a DEM, make sure that this point is where we actually want to start with one of the vents, continue on, set some thermal parameters, numerical, rheological, and then set up all of these input files where you don't actually need to do anything except for run, and then go on, continue on, and then we just spit out a little output for you. I think that's the main thing. I could talk for a couple hours about all the little things on Victor, but part of it is figuring out exactly what you need and not dealing with everything, just taking it step by step. And I think that's part of what we'll cover in the course.
Mm-hmm. Hey, Sam, could you quickly look at the desktop also?
Oh, yeah, absolutely. That's pretty important.
That's what I wanted to ask you to show the desktop.
Okay, great. So we also have a fully fledged desktop on here. There is,
again, just to get to the desktop, you go to the main launcher.
I'll do that a little quick. So you're on the launcher. You click on, there's just a D here, and it says desktop. You click on that, it'll pop out another tab. It takes maybe 5 seconds for it to load up. We have Firefox. You can just click on, on the internet tab right here, and I can go to, I go to Wikipedia, and it loads fine. It's just a browser in case you need to download something that is otherwise annoyingly inaccessible. You can drag and drop from your own PC onto Victor. That works just as well. But if it's a big file, or you want to log into something here, you can absolutely do that. It's separate for everyone else, everyone individually. We also have QGIS, which is just an open source GIS platform, but it should have everything you need. I would say I'm about 24 hours away from getting ParaView working. I understand what the problem is. It's just having small problems because of how the platform is set up. But for 3D visualization, we'll have that up very soon. And then if there's other products that people want, we'll try to get them on here as well. The only thing that I'll say we probably won't have anytime soon is MATLAB, just because of the whole licensing thing. We try to keep everything free and open source if we can. So if you have any products like that, we'd be happy to include them. All right. Anything else I missed?
GMT's on there, right?
Oh yeah, of course.
Mm-hmm. So if you're used to making maps in GMT, you can do that here and so on. So that's pretty helpful.
Can you show them somehow to open R? The launchpad, or is it working or not?
Wait, R? You said?
R, yeah.
I mean, when you say open, it depends what you want, because they can open a. I'm sorry.
Can you open it inside the terminal, or does it have also the graphical interface version of it?
I'm honestly, I haven't tried that yet. That's a good question. I could, while you're talking, I can try to figure that out. But I'm not sure if the graphical version of R is on here.
Okay, no problem.
I can check right now though.
Okay.
I mean, if you mean RStudio, that's a commercial package that is going to be difficult to install because it's a kind of very expensive license, as far as I know. But there are kind of notebooks and things like that. I think that you can still use R, right?
Hold on, I think we actually do have R. No, we have RStudio and it's connected.
Oh, okay.
Okay.
Great.
Good.
Okay.
Yeah,
if
perfect.
that's what you meant, we have it.
Yeah, perfect. Yeah.
All right. Absolutely great.
Yeah, because I know a lot of you mentioned that you were using R, so it's actually possible to actually use that on Victor too.
And you can see that it's connected to to my file system right here. So I have all these files and folders and everything, and I can use those. The last thing I'll say, I guess, is so the shared folder is readable by everyone, but only writable by admins, which is mainly our main, this main academic team and myself. But everyone has their own own file system. Everything you see besides these two folders is completely yours. No one else can see it or access it. So you can put whatever you want there. If you have a couple terabytes, we'd say, we'd prefer you not to use this as your personal storage space. But we've already all of us who regularly use it have a couple of gigs of various storage and files on here, and that's absolutely fine. So feel free to use this for your work, even if it's not directly necessary. We have
and it's important to know, to kind of keep in mind that what's in your folder is still going to be there the next time you log in. So
right. That's what I was.
Can go in and out and in and out, and it'll still be there. So it's not like an instance that then is going to disappear for you.
Besides that, we just have a lot of little extensions. We have an easy way to clone Git repositories and update them and check for changes. The Dask is for parallelizing things. We have a lot of kind of built-in products that you might want to use, and we also don't have a lot that people haven't asked for and would be easy to add. So again, as you get more familiar with the platform, if you have anything you want us to add, don't hesitate to contact. Okay. Anything now? Is there anything else I forgot?
Sounds good.
All right.
Can you switch to the new user
sure
hub? So then just want to make sure that so that's a new user one, right? So when you go new user, that's what you see.
All right. This is this isn't a fully new user, but it's a little bit less overwhelming.
Okay. So let's say you want to add a notebook and you want to share it with other people. So can you do that? Can you use this share folder to actually put your new notebook there?
So as of right now, you can't do that. So if I try to put this in, it's going to say there's an error because it's a read-only system.
Okay.
That's something that we actually have. I think we wrote about that for the geoinformatics grant. It's kind of making these subgroups, which is our goal. So you'll be able to share for specific things. Right now, we don't have that implemented, and I'm going to start talks with 2I2C about that. But right now, there's not a direct way unless you basically ask an admin to add it.
Okay. Just want to add something about the desktop. For example, if you have a notebook that is actually using some kind of interaction with an image or something like that, it's actually good when you run your notebook to have actually the desktop open, so then you can actually open the interactive window on the desktop. So the desktop is also very useful when you want to have any graphical interaction within a notebook. Yeah.
Okay. All right. I will stop sharing then. I think I've shown everything.
All right. So is there any questions at that point about anything we talked so far? Don't hesitate to ask any question, even if you think that's a stupid one. There's no stupid questions.
It's just stupid answers. If you guys want, go ahead, Sarah.
Yeah, this might be jumping the gun a little bit. Might be something that you get into when you start talking about running models and things. But I know for our purposes, we have a lot of partners who might not have stable internet connections, and so I'm just wondering what happens if you lose your internet connection, while you're working.
Very good question.
I mean, the machines have a couple hours of uptime, so nothing will change. Like, it's possible a command might not go through, but all in all, like the hub saves the state quite often, and it's all like saved on that side. So spotty connections shouldn't really be too much of a problem. Besides, at most a couple of minutes lost, but usually not more than a couple of seconds.
Awesome, thanks.
Mm-hmm.
And I guess there's no requirement in terms of like you know, how much bandwidth do you need or things like that.
No, I mean, it's better to have a stable connection, but you know, I don't know, Anat, have you used Victor yet, like in field work?
I have not logged in from the field, but it shouldn't be too much of a problem. I mean, if you just look at what we have, it's a website, and it doesn't stream videos or anything. So it does, and you're not uploading and downloading a lot. So the bandwidth requirements are actually not that big.
Do you guys want me to talk a little bit about Jupyter notebooks themselves? Because
yes,
I'm not sure how many
people are. What I was thinking is that if you could just open a new one and then show really basic function you can do to start a notebook like you did last year, that was great.
Sure. I mean, it's no problem. The hard part is sharing my screen. So please bear with me for a minute.
No worries.
I'll just share the entire screen and do our best here.
Yeah, looks good.
You guys see, so I know some people don't have accounts yet on Victor, so I encourage you to do that. But one of the first things you'll land on after you launch the server is this launcher. And you know, to start a notebook, you'll be in your home directory, and it'll look different than this one, as Sam explained. But you can still go over here and say launch a Python in a notebook environment. And so I just clicked on that button, and the screen changes to this this console, which is a Jupyter notebook. And so the idea of a Jupyter notebook is to provide a coding environment. And it's sort of more than a coding environment. So Sam was just showing some examples. But if I look at this, this is now an untitled notebook. I apparently have a lot of untitled notebooks in my directory. Not good practice, but there you go. And you know, there's a menu up here, and you can explore the menu on your own. But I just want to point out a button here. This is telling me up here that this is a Python environment. That's because I launched it in the Python environment. And there's a pull down here, and it says code or markdown. So if I go to markdown, markdown allows me to enter text in a cell. So I hope you can see the blue cell and the blinking cursor in the blue cell. And I can say this is a test notebook, and you know, just enter that. And if I go up to this sideways triangle, this run button, I can run it and it produces text. No big deal. I can also go up here, by the way, there's a shortcut. If I just hit Shift Enter in this environment, it'll run it as well, which I find pretty useful. But that's text, and I can turn it into a title by using hashtags and a space, so you can see the text turn blue, and now I get a header, that kind of thing. And here is a first short course notebook. And you know, I can now begin writing text in this cell environment. A huge advantage of Victor is I can also enter equations at this point. It uses the LaTeX format. So people say LaTeX. And it's a format that's quite compatible with the web. You can even in Word, you know, copy LaTeX equations into Word these days if you're using Word, and they'll render as equations and so on. So let's just say I want to type an equation in here. I can say $. I don't know why LaTeX uses this $, but these double $, $, symbols mean I'm going to write an equation in there. And so I'll say P equals rho GH, for example, and I'll run that. And I get an equation, a latex equation in there. So you know, I can get fancy. And if I go up to this cell, which I just ran, and I double click on it, I go back to my working environment, where I can edit my editing environment, and I can say where, say $P is lithostatic pressure, and $rho is density of the crust, $G is gravity, and $H is depth. You know, you get the idea. So I can use it literally as a notebook. And in fact, I use Jupyter notebooks as scientific notebooks now. That's the only notebook I keep other than a field book. And it's super useful because I can go back and see what I was thinking and use it. And you probably realize that a lot of people now, when they put supplementary material into a paper, people are often using Jupyter notebooks and things like that. And so now I can go to a new cell. Let me just run that again. And now I can go to a new cell, and by default it's code, so I'll just keep it as code. And so in here I can write Python code. So I can say hashtag for a comment, lithostatic pressure, and I can assign a variable. I'll just use words for variables because it's always useful. Density equals, let's say 2670, and I'll say that'll be kilograms per cubic meter. And G, or gravity, equals 10 meters per second squared, and depth equals let's say 1 kilometer, so 1,000 meters, and pressure equals density times gravity. I gotta hide this thing, I bet, times depth. Okay, and so then print pressure. So everything come on, go away. So everything I'm doing here is just sort of standard Python. And if you're not familiar with Python, totally understandable. You can gradually start building a notebook with very simple sorts of commands. Google, you know, how do I print in Python and that sort of thing, and you'll begin to be able to see what's going on as you build your way through this.
Also being on the platform and on Victor, there's already a nice collection of notebooks that you can look through for examples. So it's always so much easier to start from an existing notebook of something that's close enough to what you want to do. So it loads the libraries that you're probably going to need and things like that.
Exactly. So anyway, this is just a gentle introduction, and then you can, you know, save your notebook and, you know, do all kinds of things that you want. You can copy and paste from other notebooks and that kind of thing. So I think that's a pretty helpful way to get into it. And as Zainat said, you can use demonstration notebooks. So if I go into Victor short course, wait a minute. Sorry. Oops, sorry. I can upload things. Let me go back. Where's the shared and Victor and part 1 where I was going? So you can, as Zainat said, you can you can just load notebooks. So here's an example of the notebook we developed as an introduction to basically notebooks in Python. You can page through these things and mess around with them, own them. So this is the same format. So here I wrote some text, and I can go up to the run button and run it, and the text appears on the screen. So that's how these notebooks are made in terms of text, and you can just keep track of what's going on with the notebook, and then go down and you can add cells. You can put in as much text as you want. You can see I'm writing the book here. Nobody wants to read it. It's like a background on maps, in case you're not familiar with UTMs or something like that, and then example scripts. So you can move into this as gradually as you please. You can skip ahead. You can say, oh, this is trivial, I understand this, or wow, I didn't get what was happening in this particular case. So you can move through these notebooks. Some of these are, looking at reprojection. So this one uses a tool that's loaded on Victor called PyProj. Maybe you're familiar with it. It's based on the USGS Proj program, or Proj 4, and it allows you to do unit conversions, say from UTM to latitude and longitude, which we often face in our science. Or if you want to look at probability and statistics, here's a notebook about that. So there's a lot of resource available here. The main thing I think that's super exciting about Victor is you can just start your notebook and start working on your problem and see how it goes. And when you get stuck, you can look around on some of these other resources, or simply use the web and or ChatGPT or so on, and try to use those resources to help solve your problem. So that's a very quick introduction. I'm going to next week start on some notebooks for ordinary differential equations. We'll look at a tank problem. If you've had ordinary differential equations, a tank problem is related to sort of changes in the chemistry of or composition of a fluid in the tank over time. So we'll apply that to changing composition of lava flows over time during an eruption. We'll probably talk about some other related ODE problems. And I'm going to hope to convince you that even if you're like, oh, ordinary differential equations, I want nothing to do with those, it's okay. Victor can help you solve that. The problem of applying ODEs as well. So it's not as bad as you think, and we'll try to go there and see what happens. So what I would encourage you to do before next week is to make sure you've got your Victor account. Make sure you can launch a notebook. Try to spend some time looking around at some of these resources available to you so you can get familiar with the environment. You guys are better at this than me, but I think just clicking on buttons and navigating around is a great way to familiarize yourself, or work through a couple notebooks if you've got time to do that. And then next time, what we'll do is we'll just launch a notebook. So I hope you come and you launch Victor. You have Victor open while we're chatting, and we can work through some of these sorts of problems related to related rates and that kind of thing. So just as an introduction to sort of a physics-based problem on Victor. Is that okay? Cool.
Yeah, I think yeah. If we want to give you an assignment for next week, would be get a Victor account, start the hub, explore the hub, and come up with some questions for us. We want questions, okay? So your job would be to at least come up with one question that you want to ask us as we start the session next week. And it can be a question about anything, something you didn't manage to do on the hub, or something you didn't find and you want to ask. Okay, so it can be a question about anything that relate to the Victor hub. And I think we're going to start with these questions, and then after move on. It's really important that it's, you know, should be interactive, and you should be the one that is tailing that course to what you want it to be. So that's why, you know, the more question you ask, the more we can, you know, shift the class toward your need, and get it more interesting for you. Okay. All right. Well, thanks all for joining today. I'm going to stop the recording, and